In question 8, we have a ray of light entering a glass container containing ethanol. We have a table of values, and for part 1, we're to complete the table by calculating the missing values of refractive index n and speed v. Well, n is equal to the speed of light in a vacuum over the speed of light in the substance, which in this case is 3 times 10 to the 8 for the speed of light in the vacuum, divided by 2.2 times 10 to the 8, which gives a refractive index of 1.36. For the second entry, we're after v, which is c over n, which is 3 times 10 to the 8 again, and this is over 1.52, giving a speed of 1.97 times 10 to the 8 meters per second. For part 2, we're then to determine the wavelength of the light. Well, speed is frequency times wavelength, and frequency is unchanged, so the speed is directly proportional to the wavelength. The wavelength will change by the same proportion as the speed changes. So what we've got is the wavelength in the glass will be the wavelength in air, which we're given, over the refractive index. This is 5.2 times 10 to the minus 7 over 1.52, which gives a wavelength of 3.42 times 10 to the minus 7 meters. In B, we have a diagram something like this. We have the normal here. This is the glass, and this is the ethanol. And we have the ray of light coming down something like this. We're told this is 37 degrees. Quite unusual for the examiner to give us the angle we require between the ray and the normal. Very often they'll give us this angle, and it does catch a lot of people out, so watch out for that one. Okay. In part 1, we're told the light is instant on the glass at 37 degrees. We're to find the angle of refraction in the glass. Well, for this we can use Snell's law that n1 sine theta 1 is equal to n2 sine theta 2. In this case we're after sine theta 2, and this is n1 over n2 sine theta 1. n1 in this case is air, which has a refractive index of 1, times sine of 37 over the refractive index of glass of 1.52, and this gives theta 2 as 23.3 degrees. For part 3, without further calculation, we're to sketch the ray of light as it passes through the glass into the ethanol. Well, for here, we'll have an angle which is significantly smaller than the 23 degrees, so it'll go something like this. Then we can add a normal at this point. And now, the ethanol has a refractive index of 1.36, the glass a refractive index of 1.52. Don't forget, air has a refractive index of 1. So what will happen, the light will speed up as it enters the ethanol from the glass, but not as much as if it was going into air. So what we'd have here is the ray of light bending away from the normal slightly, but this angle here would have to be less than 37 degrees. Okay.